All right, so here's your Venn diagram. S is your sample space, A represents a specific event, and B represents a specific event, okay? For number one, we want to shade everything that represents event A. Well, everything in this circle represents event A, okay? Everything in that circle. What about number two? Everything that represents event B is everything in that circle, okay? Number three, go ahead and write this down, please. A with a U and a B. The U stands for union. That's a union symbol, but what it means is A or B. So this means A or B. So it can be an A or it can be in B. That represents everything in A or B, okay? So all of that. All right, number four, write this one down. A with the upside down U, that stands for intersection. That means it has to be in both A and in B. It has to occur in both of them at the same time. Does anybody have a guess on where I would highlight for that one?
The middle.
The middle.
Very good. Where they overlap, okay? All right. In this case, A prime, I know we've seen primes before when we did transformations, but when you're doing Venn diagrams, A prime means not A, or another way to say it is the complement of A. So A prime means not A. So again, that's something you should write down. A prime means not A. Okay, not A. That is everything that is not in A. So everything that's not in A gets highlighted, okay? B prime means not B. What do you think I highlight on this one?
Everything but B.
Okay, everything but the circle where B is. Okay. All right. Here we have A or B. That's what that means. Remember, that's what we wrote right here. A or B. And then we have the prime. So it means not that. So what did we highlight for A or B? We highlighted both circles. Well, now I want it to be not that. Where do you think I'm going to shade on this one?
The box.
Good. Outside of the circles. Okay. This means A and B, but then we have the prime. So remember that A and B, if you look back up here, A and B was just where they overlap. And now I need not that. So where do you think I should shade on this one?
Everything except where they overlap.
Very good, Samuel. All right, does anybody need more time to copy anything down?
I do.
Okay. 80 students were surveyed and asked if they take math and history classes. The results showed that 37 students take math, 40 students take history, and 14 students take both classes, and 17 students take neither class. Complete the Venn diagram to show the results of the survey. Okay. All right, so I'm gonna fill it in with pencil first and see if what we think lines up. How many total students were surveyed?
80.
80. Okay, so we need to keep that in mind. Okay, I'm going to say that 37 students take math. I'm doing this in pencil right now because I'm going to double check that everything works out. 40 students take history, 14 students take both, and 17 take neither class. If I add these all up, what do I get when I add these numbers up? Somebody tell me?
108.
Okay, thank you. So that meant that my numbers are not correct because what should it add up to, guys? What do you think?
100.
80.
80. When it says 37 students take math, it's referring to this whole circle. So that total circle is 37. Let's figure out how many students just take math. So let's talk about just this. 14 take both. How many take just math? What do you think we need to do? Anybody?
37 minus 14.
Good. 37 minus 14. Take away the students that take both, and I'm left with 23. So 23 is the students who just take math. Okay. What about how many students take just history? Somebody who didn't answer right before. How do I find out how many students just take history?
40 minus 14.
Thank you. 40 minus 14, that gives me 26. Now somebody add up all of our numbers. What do you get when you add up those numbers?
80.
80. So when you add these numbers up, you should get the total, okay? All right. Suppose one student is chosen at random. Find the following probabilities. So what is the probability that a student takes math? So this doesn't say only math, just the probability that they're in a math class. So we want to look at this whole circle now. Okay, so the probability that they're in math is this whole circle. So putting the numbers back together would give you 37. So it's 37. But remember, a probability, you're going to divide the total. What's our total number?
80.
80. Okay. And then I do want to see if that reduces. You do want to always reduce your fractions. 37 over 80. Then I hit math, enter, enter, and it does not reduce. All right, so 37 over 80. All right, so that is my answer. Sometimes the answers are in fractions. So 0.46. I don't care which way you put your answer. When you do your assignment today in Delta Math, it'll tell you whether it wants a fraction or a decimal, okay? All right, what about the probability of history? How many total students take history?
40.
Good. Out of how many?
80.
80. Which does that reduce?
1/2.
1/2. Okay. So half, or you could say 0.5, or you could even say there's a 50% probability. So there's a bunch of different ways to write your answers. Okay. What about this? Does anybody remember what this means? Is this math and history or math or history?
It's either one.
Good. It's either one. Good, Rachel. So they can be in math or they can be in history. We don't care. We just want them to be in math or history. So that is everybody except for the 17 students. So 80 take away 17 gives you 63 over 80. Let's see if that reduces. No, it does not reduce. Okay, so we'll just leave it a fraction for now. This is math and history. They have to be in both of them. The way I always remember this is an and, is I always think about an in. So this is like and. All right, so they have to be in both of them. Morgan, how many students are in both math and history?
14.
Good, it's where they overlap. So 14 over 80, we know that reduces. Those are both even. 7 over 40. Okay. Abby, do you remember what the prime means?
It means not M.
Good. So not M. So we don't want anybody in the circle of M. We want these two groups, the 26 and the 17. So there are 43 out of 80. Let me see if this reduces. No, it does not. Okay, Addie, what does the U mean? Or and? Or. So this is math or history, and then the prime means not that. I'm actually going to use the one we already did to help me. I want everybody who is not in this group. So I'm going to do 80 minus 63. I'm going to get everybody who wasn't in that group. So there's 17 students who weren't in that group. And that does not reduce. Okay. Remember, if you have a question, you can always send me a chat or interrupt me. Number 2, 40% of the students at local college belong to a club, 50% work part-time jobs, and 5% work part-time and belong to a club. Complete the Venn diagram to show the probabilities of these relationships. So I'm gonna let this be the club, this be who works part-time. And again, I'm gonna use a pencil to fill it in and see how it works. 40% belong to a club, 50% work part-time, and 5% work part-time and belong to a club. And once again, I really need to subtract those from this. The 40 refers to the whole circle. All of the people are in club, 40%. So only 35 are just in a club. And same thing for the work. I need to subtract the 5. So only 45% just work. Okay. What do you think all my numbers should add up to on this one? Anybody? What do you think they should all add up to?
100%.
Yeah,
Well, they
very
should add
good.
up
100%. All right. Percents always add up to 100. So far we have 35 plus 5, that's 40, plus 45, that gives me 85. So what percent do nothing or don't belong to a club or work?
15%.
15.
Thank you, Rachel. 15%. Okay. All right, let's see who's up. Ethan, you're up. What does C and then the U and W mean?
C is people who belong to a club, and W is students who work part-time.
Good. And what does the U mean? Do you remember? Is it or and?
Or
Or. Okay, so they can be in a club or they can work. So that refers to the whole, this whole highlighted region. Okay, you add all those up, you get 85 over 100, which does reduce. 17 over 20. Or you could have just said 85% and I would have counted it right. We haven't talked about this. This line, I really should have just changed it for the notes because you don't need to be too worried about it. It's the same thing as prime. So I really should just change it to the prime because that's not going to be on the exam, that line. Okay. All right, so this means not C or W. Evan, how many people are not in my highlighted region? You there, Evan? All right, there are 15% that's not in my highlighted region out of 100%. You can just leave your answer as 15%. I'm going to do a fraction and reduce it. Gives you 3 out of 20. Okay. All right. Isaac, you're up. What does the upside down U mean? Does it mean or and?
And.
And. Okay. So how many people are in a club and work? Peyton, are you here today? All right, anybody answer my question? How many people are in a club and work?
5%.
Good, 5%. But we want, the line means not that. So what would be the not 5%? It would be everybody else. How many, what would that be?
$95.
Thank you. So 95%. All right, thank you, Ben, too. You answered as well. All right, I'm going to reduce that. That gives me 19 over 20. All right, let's see. Tyler, you're up. What does the upside down U mean? And or?
Or.
It means and. Okay, so we want people to be in a club and we want them to not work. So we want them to be in a club and not work. Does anybody know what number we're going to use? We want them to be in a club and not work. Anybody?
35.
Very good. Because they can't work. So they can't be in the W circle. So we're left with 35. Okay. All right. Now we're going to move away from Venn diagrams and just do some regular old probability. So the probability of an event is given by the number of successful outcomes, so what you're looking for, divided by the total, right? The number of possible outcomes. And that's what we were doing up here. Okay. A bag contains 4 black balls and 6 white balls. A bag is chosen from a bag at random. What is the probability of choosing a white ball? Okay. So, Rachel, what number do you think would go on top of my fraction? We want the probability of choosing a white ball.
6.
Very good, because that's what we're looking for. It can be any one of the 6. Samuel, what do you think goes on the bottom of my fraction? What would the total be?
Would it be 10?
Good, there are 10. All right. So my answer, you have to reduce it. So 3 out of 5 is one answer. Or the decimal is 0.6. That's also a right answer. Or what would the percentage be on this one? What is 0.6 as a percent?
60%.
60%. So any of these 3 answers are correct. Okay. All right. The table shows the number of The table shows the number of seeds in a seed pod of a sample of 100 plants of specific species. Find the probability that seed pods selected at random from the samples contain. So A is 14 seeds. So we want 14 seeds per pod. Marcus, how many bags are there? How many samples have 14 seeds in their pod?
19.
Good, 19. And then you have to put it over the total. Can anybody tell me what the total is?
100.
Good, they tell you right there. So 19 over 100. Okay. That does not reduce. It's 0.19 as a decimal. What is 0.19 as a percent?
19%.
19%. Okay, so any of those answers. All right, more than 14 seeds. What do you think we need to do on this one? Anybody? How are we going to find the probability that has more than 14 seeds in the pod? All right, so take a minute and think about that. Okay, we want more than 14 seeds. So that would be 15, 16, 17, or greater than 18. All of those fit our criteria. So we need to add up all of these samples that have more than 14 seeds. So 11 plus 8, 19, 23 plus 3, 26. So 26 out of, Ben, what would be my bottom number? Good. He sent me a chat, 100. So that's 26% or 0.26. And if you were doing it as a fraction, you would have to reduce it, which is 13 over 50. So any of those answers would be correct. Okay. All right, guys, remember you can send me questions in chat. All right, number 5, when a batch of 145 paper clips were dropped into a 6 by 6 centimeter squared paper, it was observed that 113 fell completely inside squares and 32 finished up on the grid lines. Find to 2 decimal places the estimated probability of a clip falling inside the square. Noah, what do you think would be my top number? How many paper clips fell inside the square? $145 is my total, so that's going to be my bottom number. My top number needs to be how many fell inside the square, because that's what I want to find the probability of. So find the probability that fell inside the square. Yep, 113 is my top number. Okay, let me see if that reduces. No, it does not. All right. All right, now we want to see what fell on the line. Let me have Ariana help me with this one. What would be my top number for this one? Finding the probability that they fell on the line. What do you think, Ariana? What would be my top number? Are you there, Ariana? It says 32 finished on the grid line. So 32 fell on the line out of my total of 145. So you're just reading the problem, and that one does not reduce. What was extra information on this problem?
That it was a 6 by 6.
Yep, that it was 6 by 6. That was extra information. And are my answers correct?
No.
No. Why are my answers incorrect?
Because they want it in decimal form.
They want it in decimal form. So I wasn't reading very carefully. So 113 over 145. When I go 2 decimal places, that would be 0.78 because the 7 would round up. And 32 over 145 is 0.22. Okay. All right, Jaden recorded the grade level and instrument of everyone in the middle school of Rock below. 7th grade students and 8th grade students. Based on these results, express the probability that a student chosen at random will play the keyboard as a fraction in simplest terms. So we want a student chosen at random to play the keyboard, and we want to leave our answer as a fraction. Okay. So we are choosing a student at random. So are we choosing from the 7th grade, 8th grade, or everybody?
Everybody.
Good, we're choosing from everybody. It just says a student chosen at random. So we're choosing from all of these students. Somebody add these up, add all the numbers up and tell me what you get.
$78.
78, can anybody else confirm that?
Yeah, I got 78 as well.
All right, so 78 is our total. And then we want them to play the keyboard. So that's what's going to go on top. How many total students play the keyboard?
16.
16, very good. And we have to make sure we reduce it if possible. So 16 over 78, math, enter, and 8 over 39. So that is my answer, okay? Annabelle has a bag that contains strawberry cheese, cherry cheese, and lime cheese. She performs an experiment. Annabelle randomly removes a chew from the bag. Then she returns the chew to the bag. She does the experiment 39 times. The results are shown below. Based on these results, express the probability that the next chew Annabelle removes from the bag will be a cherry chew as a decimal to the nearest 100th. Okay, let's see who's up. Lizbeth, you're up. What do you think my top number is going to be on this one?
3 because it has to be for the cherry chew.
Very good. And Brendan Hooper, what do you think my bottom number is going to be?
Um, 36.
Close. 39. All right, so 39 is your total. So I need to do a decimal to the nearest 100th. So that's 2 decimal places. So let me put this in my calculator. 3 over 39. We'll go 2 decimal places. So that would be 0.08 because it rounds up. So as a decimal, it's not a percent. You're going to leave it as a decimal. Okay, so 0.08. In a popular online role-playing game, players can create detailed designs for their characters' costumes or appearance. Colton sets up a website. Information about the number of people who visited the website is listed below. Based on these results, express the probability that the next person will purchase no more than 1 costume as a decimal to the nearest 100th. They will purchase no more than 1 costume. Okay, who falls into that category? People who purchase no more than 1 costume. Who falls into that category?
People who purchase no costumes or 1 costume.
Very good. Both of these people meet this criteria. No more than 1 is 0, or 1. Okay, so you have to do what? What do you think I'm going to do with these two numbers, guys?
You add 16 and
them.
162 together and then divide by 1.
Good. You add these together. So that gives me what? Sorry.
It gives you 178.
178. My brain is slow this Monday. All right. And EJ, what do you think my bottom number is going to be? What do you think I need to do to get my denominator?
Would you add up all the numbers?
Good. Add them all up. So that gives me 192. All right. I've got to do a decimal to the nearest hundredth. 178 divided by 192. And the nearest hundredth would be 0.93. All right, number 9, Elizabeth owns a small business selling bagels. Based on these results, express the probability that the next customer will pay with something other than cash as a percent to the nearest whole number. Jacob K., who will be people paying with something other than cash?
People paying in debit and or credit.
Good. What do I have to do with those two numbers?
Add them together.
Good. Add them together. That gives me 93. And then Riley, how would I get the denominator? How would I get the bottom number?
I do not know. Not
You have-
going to lie.
You have to add all of the customers up. Okay. Your bottom number is your total. Okay. The total people. All right. We need to do this as a percent to the nearest whole number. So 93 divided by 109. So it's 0.85, but that's a decimal. Lorette, what is 0.85 as a percent? How many places do you move the decimal? Do you remember?
2 slides to the right.
So it's going to be 85%, and they want it to be a whole number as a percent. Okay. 2 more, guys. A spinner is divided into 5 colored sections that are not of equal size. Red, blue, green, yellow, and purple. The spinner is spun several times, and the results are recorded below. Based on these results, express the probability that the next spin will land on red or blue or purple as a decimal to the nearest 100. Terry, how am I gonna find my numerator, my top number? What do I need to do?
You gotta add 20, 6, and 12.
Very good. The red, the blue, and the purple. So 26 plus 12, that gives me 38. And then Anna, what about my denominator? What do I need to do?
You need to add up all the rest of the numbers. So you need to add up 26, 7, 3, and 12.
Good. And remember, y'all can also use Desmos. It will also give you decimals and fractions. So this one, it wants to go to the nearest 100th. That's 2 decimal places, so 0.79. Okay. All right. Based on these results, express the probability that an 8th grader chosen at random will play an instrument other than the guitar as a fraction in simplest terms. This time, I'm only looking at what grade on this problem. What am I only looking at?
Eighth.
8th grade. We're not going to use these numbers at all because we're choosing an 8th grader. We want them to play something other than the guitar. TJ, what do you think how are we going to find our numerator? What do we need to do?
You need to add together all of the numbers which are not the guitar, which is 22.
Good. So you add the numbers that are not guitar, which gives you 22. Lizeth, what about my denominator? What do you think that's going to be?
You add all the numbers of the 8th grade students.
Good. So again, I'm only looking at 8th graders because I'm choosing out of 8th grade. I'm choosing out of 8th grade. Okay. And I want to see if that fraction reduces. Let me show you Desmos real quick in case you have forgotten. Sorry, my computer is pretty slow this morning. All right, so 22 out of 29. And then here's how you reduce the fraction in Desmos. You hit the fraction on the left-hand side. You hit the fraction circle, and that will reduce it to its simplest form. So 22 over 29 is already reduced. For instance, let's say you had 50 over 100. If you hit this fraction, it will give you the reduced form. So 22 over 29 is your answer.